So you guys got the last week's quiz back. If you still have any questions about it, or if you take a look during the break or something, if you have any questions about it, I can go over that with you. I don't plan on going over the whole quiz. Most of you guys did pretty good. I think the average was 91, standard deviation of 10, which means that most people fit between 81 and 101, right? So that was pretty good. Good job. If you didn't do so well, you get another chance tomorrow night, because there's another quiz tomorrow. At the end of class today, the last thing we'll do is go over the practice quiz that I sent online that you should have seen. But if you haven't, I will hand out a paper copy with the answers, and then we'll go over that and be ready for tomorrow's quiz. So the stuff we're going to learn tonight is not on the quiz tomorrow. Okay? So that doesn't mean don't pay attention. In fact, this stuff can get kind of tricky, especially stuff we do at the end of tonight. But we'll go over this, and the next quiz won't be for 2 weeks after tomorrow. So it's going to be a longer one. Yes, Amy?
Do you grade on a curve?
I don't grade on a curve normally because it's not necessary, only because most grades are within a decent range. If for some reason I give a stupid question on a test, which I did last time, and everybody gets it wrong, I'll just ignore that one, and that'll be kind of like a curve. I'll give everybody the 5 points or whatever, but.
Did everybody get 5 points?
No, sorry, in the last class. Not in this class. I haven't given a question that you guys shouldn't know how to do yet. All right. You do not need graphing paper. No, you can sketch all the stuff we're going to do tonight. No problem. Thursday night, there were 3 people here, which is fine. It gave those 3 people lots of good chance to learn the stuff, right? But some of you guys possibly might consider coming to some of the Thursday sessions because it's a little more in-depth and lots of practice on stuff, okay? So it's not mandatory, and unless you're like failing the class, which none of you are, then I won't make it mandatory, but until, I just suggest coming. I'll leave it at that. Okay, questions on the quiz or tomorrow's quiz or anything? Okay. Tonight, we're going to be talking about graphing and functions, okay? And what functions are, we'll define exactly what functions mean. But the first thing we need to do is we need to figure out what we mean when we say graphing, okay? You've all seen graphs before. I'm quite certain of that in some form or another. But we generally write a graph like this on what we call the Cartesian coordinate system. C-A-R-T-E-S-I-A-N, the Cartesian coordinate system, which means there's an x-axis. We normally do it x. Sometimes you'll see it as t or some other variable. It doesn't matter. It doesn't have to be x, but generally it's going to be x. And then the one going this way is going to be y. There's actually little arrows on all these because this coordinate system goes on forever in all the directions. Okay? And what this allows us to do is to basically graph the algebra that we're talking about. Okay? You can graph some of this algebra stuff, especially the things with 2 variables, because it fits nicely on this graph. If there were things like 3 or 4 variables, not so easy to do, right? But we'll do relatively straightforward types of graphing in this class, okay? On the coordinate axis, okay, we call this one the x-axis or the horizontal axis because it's horizontal. This one we call the vertical axis because it is up and down or vertical. Okay. I will almost never talk about this, but sometimes you might see the different corners of these labeled. These are called the quadrants. This is called quadrant 1, and they use like a Roman numeral 1. This one's called quadrant 2, and then this one's quadrant 3, and this one is quadrant 4, like that. Okay, 1, 2, 3, 4. And that just tells you where on the graph you are. Okay, what kind of section, what kind of particular section you're in. Okay? We call the point right here the origin. The origin. Okay? And then we label the numbers given whatever scale we're talking about. So if you had to graph things where they were like 100 and 200, you don't want to label 1, 2, 3, 4. You'd be 7 boards down, right? You would do it based on how much you're going to have to graph. You don't always know how much you're going to have to graph until we actually get there, but it's generally not too hard to change your axis. In this case, I will just number it 1, 2, 3, 4, 5. 1, 2, 3, 4. Going this way from 0, this is 0, comma 0, meaning this is point 0, 0. -1, -2, -3, -4. Same thing going on the y-axis. Up is positive. 1, 2, 3, 4, and down is negative. -1, -2, -3, -4. Anybody have a problem with that so far? What we're going to do is we're going to use this graph to plot various points. So for instance, if I want to plot some points, I can plot 5, 1. And what that means is this is the x value, and this one is the y value. And what we do generally is you take the x value and you go on the x-axis over to that value. So in this case, it would be 5 here. And then you go to the y value. 5 over and 1 up, that is 0.51. We put it in parentheses with a little comma. 5, 1, right there. No. Did I, what?
No, I'm talking to myself.
Oh, all right. No worries. If we want to do -2, 3, same thing. You go over to -2, and then you go 1, 2, 3 up there. And I am not going to worry about where on here you, like, I'm not going to worry about it being exactly right there. -2, 3 on these sketches. On the homework, if you haven't gotten to this on the homework yet, you have to graph some things. You can either use the arrow keys to like arrow over the little dot to where you want, or sometimes you have to actually click on it and then put your mouse there. It's a little tricky, but not impossible. You'll figure it out pretty quickly. And then we also have ones like -3, -7. Same thing. You go over to -3, 1, 2, 3, and then you go down 7, 5, 6, 7. -5, -6, -7. So -3, -7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 down there. -3, -7. OK? Anybody have any heartache with that stuff? OK, we'll do lots of that practice here. Now, what we can do is we can graph equations. OK? So we can graph equations that are in, as I said before, in 2 variables. Let me do this. Let me actually, I'll erase. Can I erase it? Anybody still drawing the graph? No? OK. I'll erase it. I'll put another graph up in a little bit. But for now, we can talk about graphing equations in 2 variables. So for instance, if we had y equals x squared minus 3, eventually we will be able to graph this fully, like the whole graph of this. But for now, we're just going to focus on individual points. OK? So this graph might express some formula for something like if this was the speed you were going, this might be your fuel economy, something like that, right? Or it might be the units of production and the cost, or the cost for so many units of production, or something like that. But it's just a form, it's just a little model of something or other. OK? And a solution to that is what we were just talking about, these like points, x point and a y point, that might fit on here. OK? In fact, 3, 6, let's see if this works. What we would do is the 6 is the y, and the 3 is the x, right? So you'd say 6 equals 3 squared minus 3. 6 equals 9 minus 3. 6 equals 6. So the solution, 3, 6, or the ordered pair, we call this, 3, 6, is a solution to y equals x squared minus 3. Make sense? All we did was we did. And you can figure out one from the other. If you know one and not the other, right? If I said, and we did this for the quiz the other day, I think, y equal, well, let's do x, easier one. If I said x equals 3, what would y be? Well, you'd figure it out. Y equals 3 squared minus 3, and you'd end up saying y equals 6. Right? So you just plug in one of them, and you can figure out the other one. Kind of straightforward. OK? All right. The graph of the equation is the set of points that are all solutions of these equations. And we're going to graph all the different points. OK? So one way to do a graph of this is to just start listing out points, OK, in a little table. So let me do this. I'll do a table right over here. as follows. I will say x, and then I'll have a column for y, and then I'll have a column for the final ordered pair. Okay? Well, let's see if we can figure this out. This is going to be for y squared, or sorry, y equals x squared minus 3. Okay? For the one we just did. Y equals x squared minus 3. Okay? All right. Start picking points on here. Hey, Dawn. You start picking points on here, and you'll say, OK, let's just pick some points. A lot of times you have to pick points that you kind of guess on for this method, but it's OK. Let's do the points -3, -2, -1, 0, 1, 2, and 3. We'll just pick those and hope that when we graph this, they give us enough information to do the whole graph. They should. Okay? So same thing we did before. We do x squared. We do -3 squared minus 3, which is what? -3 squared? 9 minus 3? 6. So our final ordered pair is -3, 6.
You lost. Where are you getting
-3 I'm making up. I'm just picking these out of thin air. But I'm doing it in an order.
Where are you getting the y one from?
OK, the formula is right here.
Oh, okay, got it.
Right? So then I'm just going to say -3 squared minus 3.
Got it.
OK, good. All right, -2. So we do -2 squared minus 3. -2 squared? 4. Minus 3? 1. So we get -2, 1. -1 squared minus 3. -1 squared is 1. Minus 3 is -2. So we get -1, -2. So far, you probably can't tell much of a pattern over here yet, but we'll see what happens here. 0. You're going to get 0 squared minus 3 equals 0 minus 3 is -3. And then 1 squared minus 3 is now 1 squared is 1 minus 3 is -2. Now, I forgot about this one. 0, -3. And look at this one. 1, -2. There's -2 shows up there, and this is just -1 and 1. 2 squared minus 3. 4 minus 3 is 1, 2, comma 1. Well, look at this. -2, 1. There's going to be a little bit of a pattern here, which we'll start to see. And this one's finally going to be 3 squared minus 3 equals 9 minus 3 is 6. 3, comma 6. And we started out with -3, comma 6. All we do now, we have enough points on here, we quickly sketch it. So you draw a little graph, label x and y, and then what are we going to go from? On the x-axis, we've got to go from -3 to 3. So we can do maybe 1, 2, 3. And -1, -2, -3. On the x-axis, we have to go all the way from 6 to -3. That looks like it. So let's just do, we can also do by ones. 1, 2, 3, 4, 5, 6 way up there. And -1, -2, -3, -4. We don't need to go anymore. If you want to keep going, you can. And then we just sketch it. -3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Right there. Okay? And I'm not going to put the actual coordinate just because the graph will get a little messy. -2, 1. -2, 1. Okay? -1, -2. -1, -2. There. And 0, -3. 0. Don't need to go across at all. -3. How about 1, 2? Now we go over 1. Sorry, 1, -2. Go over 1, down -2. And then 2, 1. So we go over 2, up 1. And then 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. All right. Can anyone see what this might look like? Yeah, I see it. Whoop, right? It's called a parabola, right? And what you do with this is you just kind of try to sketch it, getting all the points in there and doing little curves as you go. Don't just connect the points. It should be kind of a curved line. That is called a parabola. Eventually, we will learn a better way than to do all these points out to actually graph this. Okay? But that's it. Now, if you'd picked some other point, let's say you'd picked -2.5, Well, negative 2.5, you should get a value around here, right? Because that's about 2.5. So it should be a little bit above 3 or something like that if I sketched it quite correctly. Okay, but you don't need all the points to make the graph. Okay? But that's called the point plotting method. Okay, because you're doing a bunch of points, and then you're plotting them on the board. Straightforward stuff. Okay? All right, let's do another example of this. Anybody still writing these ones down? OK, I'll wait. What we're going to do is we're going to do a little word problem. And you're going to convert the word problem into this point pair. OK? And we're going to have two different equations here. We might run out of board space. But we'll try to do it. In fact, I don't think I'll write the pairs down. We'll just grab them off the rest of it. OK? What we're going to do is, this is the question. The toll to cross a bridge costs $3.50. A monthly pass costs $20, and then $1 per trip across. While the monthly pass doesn't just get you free forever, but that's the way to do it. I'll write it down. Yep. OK. I'm going to, while people are still writing that down. OK. So you have a toll. The toll is either $3.50, okay, per ride across, okay, or $20 per month plus $1 per ride. Okay, $1 per ride. That's what we're going to do. Now, you would have to be able to pick that out of the words if I wrote all those words out. But I simplified it a little bit up there. OK? All right. Can I erase this now? All right. So we're going to actually do we're going to do 2 more sets of points here for the 2 things that we have up here. OK? Let's see if we can convert this into a couple of different equations. OK? $3 per ride. And we're trying to figure out the monthly cost of riding the monthly cost is what we want of riding across this bridge in those 2 different cases. Monthly cost, question mark. Okay? In the first case, the monthly cost is actually pretty easy. Every time you go across, you add $3.50, right? Or the number of times you go across times $3.50 gives you the total. So if we say that the monthly cost is y, for the first one, it's just going to be 3.50 times if x is the amount you pay per ride. Isn't that true? 350 times the number of times you ride. If you rode once, it'd be $3.50. If you rode 10 times, it'd be $35, etc. OK? All right, the other one. Now, same thing. We're going to have, I'll do it over here. Y equals, like this. I'll hopefully be able to fit the graph over here. It'll be a small graph. In this case, you have this fixed cost for this other one of $20. You go down to the bridge the first day, and you pay your $20, right? And then you cross over, and it's $1. So isn't it true that you pay $20 plus 1x, or just x, right? OK, and that's your pass. Let's do these 2 graphs and see. The big question is going to be, how many trips do you have to take before it breaks even, or before you want to do the before you want to do the thing? Dave, question?
I was saying this is a lot slower than we learned last week how to do this. Right?
Oh, well, we didn't really learn it quite last week. We learned part of it last week. We will relearn it. We will learn a better method by the end of today. So this is slower, yes. But I want you to see the graphical part of it because it kind of leads to a little bit of more understanding, I think. OK, pretty simple stuff. Let's do this. Let's pick some points. And I'll pick some points like this, x and y. OK, and it's going to be, let's pick by 2s. 2, 4, 6, 8, 10, 12, 14. OK? For y equals 350x. OK, well, this is not too bad. You're just going to do this times 3.5. 2 times 3.5 is 7. 4 times 3.5? 14. You're adding 3.5 each, well, you're adding 7 each time, right? 6 times 3.5, 21. 8 times 3.5, 28. 10 times 3.5, 35. We already said 10 trips cost 35, right? 12 times 350, 42. Add another 7. 14 times 3.5, add another 7, 49. There's our x and y coordinates. That wasn't too slow. Not super fast, but not too slow. Okay? Tell you what, in the interest of having lots of space for my graph, I'm going to write this one. That's going to be that one. And then this one's going to be y equals, what do we say, 20 plus x. OK? Let's do the same x and y values here. X and y. 2, 4, 6, 8, 10, 12, 14. And now all you have to do to get the y value is add 20. 22, 24, 26, 28, 30, 30, 32, and 34. Also not too particularly difficult, right? For ones like this, isn't too bad. Okay. Now let's graph this. Both of these. We're going to graph 2 different equations here. Okay, and we're going to see what happens. I'm going to do them in 2 different colors too. Okay. What are the numbers we're going to have to, in fact, let me do it this way so I have even more room. Are there any negative numbers on here? No. So let's make the y value down to here and the x like here. So I'm just getting rid of quadrants 2 and 3 because it doesn't really matter. This is still 0. This is still 0, 0 right here. But this is now x and this is y. OK? Should even label it y and x like that. And let's actually graph this. So what do we need to go up to on the x-axis? 14. So let's just go up to, say, 16 or 14 or 16. You can go by 2s if you want. Why not? 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. You do have to label what you're doing. You can't just put hash marks and expect somebody to figure out what the numbers are. You do have to label them. And what do you have to go up to? There's 34, but there's also 49. Let's go up. What do you want to go up by?
5.
I like 5. That's good. How about this? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50, like that. OK? Now you just graph them. Let's graph this one first. 2, 7. Over 2, up 7. You have to kind of guess on some of these where 7 is, but it'll get pretty close. 2, 7. 4, 14. 4, 4, 14. 6, 8, 6, 21. Thank you. 6, 21 is about there. 8, 28 is about there. Notice something about this line. Should be pretty straight. 10, 35 should be about here. Well, pretty straight. 1242 is about here. And 1449 is about here. Okay? And I had a ruler around here somewhere.
Right there.
Where is it? Oh, all right, that one will do. I had a yardstick, actually. It'll work better, but this one will be all right. I'll have to kind of connect it. So yeah, I didn't do these points exactly right. But you're generally going to get a nice straight line here for these ones. And later in the class, we'll talk about what happens if it's not a straight line, like, so I didn't do these quite right. But these ones should be direct and absolutely straight line. You end up, if they're not a straight line, you actually just go through as many points as you can, or close to as many points as you can. But in this case, it should be a straight line, because this is actually a linear equation. OK, so that's one of them. Now I'll switch to orange pen for the other one. 222, 222 here, about there. 424, about here. 626, about here. 828, about here. 1030, about here. 1232, about here. And 1434, about here, let's say. Still, my lines aren't quite straight enough, but that's all right. OK. What we can do now is, again, draw a little straight line best we can. If I had done my points properly, that'd be a perfectly straight line. Okay? And let's say that was there. And the question is, where's the break-even point? Right where they cross. Okay? So that's the break-even point. In this case, you can pretty much read this off the graph. It's right about there. It's not going to be perfect, again, because my lines aren't perfect. But in this case, it's going to be about 6.5 and 25 or so, something around there. Does that make sense? Maybe I didn't read it off right. Actually, you know what? It's actually closer to 8. It should be closer to 8. It should be closer to 8 and about 28. So yeah, let's pretend that's 8, 28, except my purple pen's not working. Okay, 8 and 28. Okay, that's where it actually ends up crossing. Okay, and that's where it is. So what this means is, if you spend x values was x was what? The number of trips. If you did 8 trips, it wouldn't matter if you paid your $3.50 per ride or if you paid 20 plus $1 per ride. Okay, because that's 28 in both cases. Okay, it happens to be 28. And by the way, you could have read it off here too, 8 and 28. See, are they both there? I don't know why my 8 and 28s didn't come out right, but it should have been. Okay. If you are doing more than 8 trips, which one is going to cost less? And by the way, remember the y is the cost. Which one is going to cost less if you do more than 8 trips? Yeah, the orange one. Because can you see how the orange one goes up slower? So you end up doing, it doesn't get as much cost the longer you go by. If you still did the $3.50 per trip, it's going to cost more and more and more. If you do less than 8 trips, look, this one, the blue one, which is the, and by the way, we should probably label these too. Should have probably said this one is y equals 3.5x, and this one is y equals 20 plus x. Okay, like that. Okay, and you'd say the y equals 3.5x is the one that you're going to get to go. Rough day, huh? All right. Okay, any questions on this one? Yes, Juan.
So what is the next?
What is it? What? What's the? Well, what was the question? The question was, well, I didn't actually ask for it. The question was, how many rides do you need where it breaks even? In this case, it's 8 rides, and the cost is $28. Okay. All right. So that's the basic stuff about this graphing stuff. Okay, we'll do a little bit more graphing in a few minutes. Okay. People still drawing this one? No? Okay. The next thing we're going to talk about is these things called functions. Okay, now we've been dealing with functions this whole time, but we haven't explicitly called them functions. Okay, this is functions. For whatever reason, and maybe because I didn't explain it well in the last class I taught, the students, for some reason, did not quite grasp the idea of what a function actually is. Even though I talked about it a lot, I just didn't explain it very well. So let me explain it, and then we'll get your questions out here if you can't figure it out. Okay, if an equation, okay, so an equation has, if an equation, okay, has 2 variables, okay, x and y, and gives exactly one answer, or I should say one value of y for each value of x, okay, then we say that y is a function of x. Perfectly clear. Just kidding. Let's go through what this means. You have a function, okay? So let's say it's a function that says the following. Let's say we had y equals 3.5x, the one we used for the toll. Okay. Does it have two variables? Okay. Does it give one value of y for each value of x? Here's what that means. Remember how we graphed it like this, right? And it went something like that? For every time you pick out a y value, is there only one x value associated with it? I go right there. There's my y value. All right. Is there only one x value there? Okay. Sorry, I did it exactly. I told you exactly backwards. Should be the other way around. For every x value, is there one y value? In other words, I pick an x value, and I go, bing, there's one y value. Pick an x value, there's one y value. Okay? That means that it's a function, y is a function of x. We can write this in a different way that always seems to confuse people. What we say is the function of x equals 3.5x. What's the only thing different from this equation to this equation? F of x and y. Which means that in this case, we're saying y equals f of x. So if you see f of x, you can replace it with y. This is the part that everybody gets confused about. If you see f of x in the equation and you go, I don't remember what that means, just put y back in there, and then it might make a little more sense. What's nice about this form is that you can say things like f of 10. And note what's the only thing different about these two? The x becomes 10 equals 3.5 times 10. In other words, where we see x here, we replace it with x here. And this is going to be your answer to the equation. If we plug in the little 10 there. What would f of 2 be? 3.5 times 2. Okay, f of negative 6. 3.5 times negative 6. Okay, that's how this goes from here. What we're saying is the y value is whatever you get on the other side. This ends up being the y value, because isn't it y equals 3.5 times x? So in this case, 3.5 times 10 gives you the y value. Even though you write it like this, and it seems a little confusing. You write it like this. You plug in that value. What you get is the y value on the graph. Okay? I'll go over that lots of different times. Okay? All right. Let's look at an actual example. Everybody write down this, the words here? OK. Let's do an example here. Supposedly a real-life example, I guess. All right. OK. Here's a function. F of x equals 0.0875x squared minus 0.4x plus 66.6. Now, that looks kind of crazy. And Nadia's like grimacing. It's not that bad. All this is saying is some function of x is given by this value here. This happens to be the car's stopping distance if you're driving a certain miles per hour. Okay, so if you plug in the miles per hour here, you get some answer, which is the number of, it turns out to be feet that it takes you to stop, unlike dry pavement. Not on ice or whatever, right? Dry pavement, you plug in your value of how fast you're going there and there, you calculate it out, and that gives you how far it's going to take you to stop. Is it a perfect model? No. Some cars have better brakes. It's on only a particular surface, et cetera. But in general, we say we can use this example. Okay? What if we say we replace f of x with? Y. So really, this is just saying the function y equals that. If we picked a bunch of x values, couldn't we plug into here, get a bunch of y values, and graph it?
Yes.
It's exactly like we did before. No differences than doing that before. We just say it's f of x. Okay? We say it's f of x in this case. And those are the values we could plug in. So if we plugged in 1, if we said f of 1, what would you plug in up here? 1. And then you'd get some value. I don't actually have it on here. But I don't have it on here. But you would end up doing 0.0875 minus 0.4 plus 66.6. You'd get some value. That would be the y value that you would graph on the graph. Okay, let's just plug 1 in at least. And if you don't have your calculators, you may be in trouble, or you'd have to do the same thing. But I'll give you a calculator if you need it. Function of 20. I'm going to plug in 20. 0.0875 times 20 squared minus 0.4 times 20 plus 66.6. Plug that in. Who needs a calculator? One. Anybody else? Oh, there you go. One of these days, Amy, I'm going to crush you with the calculator. I know. Anybody else? OK. All right. All right, let's see. 0.0875 times 20 minus 0.4 times 20 plus 66.6. How about 93.6? OK. This equals 93.6. And in this case, we said feet. So if you're going 20 miles an hour, and you slammed on the brakes, OK, and you're on dry pavement, it would take 93.6 feet to stop. Now, this is probably not true if you're in an up-armored Humvee or something, right? Because it takes longer to stop or whatever. But if you're in like a regular car, anyway, this is the model we might use. And what you would do is you would graph this, and you'd go, this is our x value, 20. Even though it's on this side, x is the 20. Remember, we plugged in 20. You'd go over to 20, and then you go up to 93, wherever that is. And you'd graph it. And that would be the point if you wanted to graph this. OK? It's not too bad, I hope. We'll do more examples of this stuff. OK, we'll do more examples. Everybody still writing this one down? OK. All right. Here's another pretty simple example. F of x equals 2x. F of x equals 2x. We're going to graph this. X, and we're going to do a bunch of points. X and f of x, but what do we say f of x really is? Y. So I'm just going to put y in parentheses up there. OK, so if you have, let's do -2, -1, 0, 1, and 2. -2, f of x equals 2x. If -2 is in there, what would this one be? 2 times -2, which is -4. Just multiply this one by 2. -1 times 2? -2. 0 times 2? 0. 1 times 2? 2. 2 times 2? 4. You graph it. Pretty simple to graph. We're going to go from, let's see, on x, -2 to 2. -2, -1, 0, 1, 2. And then -4 to 4 on the y-axis. 1, 2, 3, 4. And -1, -2, -3, -4, -2, -4, -2, -4, -1, -2, -1, -2, 0, 0. Oop, right there. 1, 2, right there, and 2, 4. There. And my scale isn't quite right. But anyway, there you go. That's your equation. Question, Rennie?
I got the whole equation mentioned, but for the x and y factors, is that always just going to be something you make up?
Yeah, in this case, if you're going to try to graph this out of your head, just out of nothing else, you just make up the x values.
Okay.
Y values come from the the formula.
So it doesn't matter what
You can put anything in here. But you try to want to put something near 0 if you can, and see if it's in there. It won't always be near 0. OK? All right. Going back to that question about if for every x value there's only one y value, I will ask you this on the next quiz. I'll tell you right now. You can figure it out from the graph. You can figure out if something's a function by doing this thing called a vertical line test. For instance, let's say you had that circle right there. Is that a function?
No.
We know it's not a function because for every x value, there's an x value. How many different points of y are there? There's at least 2. Well, there's 2 in this case, there and there. Not a function. How do we know? We draw vertical lines through it. If the vertical lines ever hit 2 points, you know it's not a function. That's it. It's going to be the easiest question on the entire quiz. OK? Here's another one. Let's look at the parabola we talked about before. Is that a function?
No. No.
Who's saying no? Why no?
Wait, my bad. You said vertical line.
Yeah.
Gotcha.
So a vertical line there, does it ever hit more than once? No. How about there? No. How about there? No. Always only hits once is a function. Ta-da. Okay. How about a sideways parabola? Not a function. Hits twice. Okay. Let's see. It doesn't matter where on the graph it is either. If the sideways function was here, still wouldn't be a graph because you still do it showed that vertical line tells you right there. Okay. Let's see. Those of you who took trigonometry, don't worry if you didn't. You're not going to have to know anything. Let's see. This happens to be a sine curve. Is that a function? Sure it is. How about a? This is a different. This is one like this. Function?
No.
Nope. Vertical line. Oop. Hits twice. Hits lots of times. Right? Okay. Pretty easy stuff, right? That's how you tell graphically if something's a function. Okay. And there's reasons we care about that. Mathematically, you don't. It's harder to deal with function. It's harder to deal with algebraic equations that aren't functions because of the way you plug things in. But we're always going to deal with functions in here. Okay? All right. One last thing on this stuff. If we have a function that looks like this, 10, 20, 30, 40, and 50, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X and Y. By the way, you don't have to have the same scale on both sides. It doesn't matter at all. Okay? Let's say we had, let's say 1 and 30, 1 and 30, and 2 and 50, and 3 and 10, and 4, let's say 5 and 20, like this. And I drew a nice curve like this. First of all, is it a function? It is. Vertical line test passes. Okay. Second question is, this is in, let's say this is in thousands. And what this is the number of people logged onto some website at a particular time of day. So at 1 p.m., there's this many, 30,000. At 2 p.m., there's 50,000. At 3 p.m., there's 10,000, whatever, some website. Okay, and this gives the number. We can actually approximate some of these things using this graph. So if I said, how many people are logged in at 4 p.m.? About that many, which is what? About 12,000 or so, right? This is kind of an important thing because a lot of times you'll see graphs various places and you'll say, I got to estimate something from those graphs. We will do a lot of that on quizzes and things. Okay? You could also say, at what times are about 20,000 people logged in? How about here? About 2:30? 2:30? 30? Or where else? 5 p.m. You couldn't say, it wouldn't make any sense if this wasn't a function. Like, let's say it looked something like this. Right? 1 p.m., 2 p.m., 3 p.m., 4 p.m., 10,000, 20,000, 30,000, 40,000. If I said, how many people are logged on at 2 p.m.? Or, see how those? That doesn't make any sense. There can only be one amount of people logged on at a certain time. That's one of the reasons if it's not a function, it's not going to make sense in some cases. Like for this one, that can't be a function because it doesn't make sense because you can't have more than a certain number of people logged on at any given time. Okay, so not a function, and that's it. And we have to be able to estimate this stuff. Okay, all right. Whew, that was a lot to learn in 45 minutes. You guys want to take your first break?
Yeah.
Let's do it. Come back at. All right, I'll give you till 7, but we do have a couple other things to do. Now we have to do linear functions. We're still working on linear functions or functions and their graphs. But now we're going to do section 7.2, linear functions and their graphs. Now we've already done some of this. You've already seen these, but we're going to make it a little more explicit. Suppose we have a function, f of x, and this should not scare anybody. That just means y equals negative 3x plus 6. Okay? You could also write it y equals negative 3x plus 6. Okay? We call this a linear equation in two variables. Okay? We call this a linear equation in two variables if it has the following form. Y equals, sorry, I should rewrite it like this, not y equals. A times x plus b times y equals c. How about an excuse me? Whoa. All right. A times x plus b times y equals c. Can I rearrange this such that this is something times x plus something times y plus something else? Sure, I can. Okay? I'm not actually going to in this case because we don't actually need to. But what we're going to do, the easiest way to graph this, you can graph these so easily. You don't have to do the whole piece that we did. You can do this so easily because remember, these equations are lines. That's what linear means, by the way. Line is actually built into the word, right? It's a linear function because it will create a line. The easiest way to do this is to find the intercepts, okay? Which means where the line crosses the x-axis, or the y-axis, and where it crosses the x-axis. And the easiest way to do that is to realize something. If a point is on the x-axis, what is the y value? 0. Y equals 0 right there. If a point is on the the y-axis, what is the x value?
0.
X equals 0 right there. So if you plug in x equal to 0, you get the y value for the x-intercept. Let's do it in this case. Plug in x equal to 0, we get y equals negative 3 times 0 plus 6. Y equals 6. Where y equals 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, that is your x-intercept. Nope, I lied. That is your y-intercept. Okay? That's your y-intercept because it intercepts or crosses the y-axis at that point. Okay? Let's do y equal to 0. 0 equals negative 3x plus 6. Do we know how to solve for x? Sure. The first thing we would do, let's not divide by 3 quite yet. You could, but let's subtract 6 first. Negative 6, negative 6. It would work out the same in this case. But you get negative 6 equals negative 3x, and then what? Divide by negative 3, and you get 2 equals x. Okay? 1, 2. That's your x-intercept, because that's where it crosses the x-axis. Lines are defined by any 2 points on that line. Do we have 2 points that are now on that line? We do. So you can take your fancy ruler, and you can say, whoops. All right, let's pretend that was a nice straight line there. That's now your line. And that is the line y equals negative 3x plus 6. All we did was we set x equal to 0. We found the y-intercept. We set y equal to 0. We did a little bit of algebra. And we found the x-intercept. You got the 2 points. You draw a line through them. That's your line. Not so hard, I hope. Do some more examples of that. Okay.
I still don't get the ax plus by equals c.
Any equation in the form ax plus by equals c is considered a linear equation. There's no squareds in there. There's no other variables. There's no, as long as it can be rearranged in this. You can't have something like this, 5xy plus x equals 0, because you can't get rid of the x in that case and the y together. It's got to be something like 5x plus 6y equals 0 or equals 9 or something like that. You've got something times x plus something times y equals some other number. You can rearrange things like this. To do it, we'll just do it, right? Let's see. If we want to make it equal to 6 over here, let's add 3x to both sides. Y plus 3x equals 6. I'll rearrange these because you can commute them, right? Commutative property. 3x plus, I'll write the 1y equals 6. Isn't that in that form?
That's what I was thinking.
Yeah.
Okay.
OK? Yeah. So you can do it that way. All right. Let's do another example. Let's do the example 2x plus 4y equals 12. 2x plus 4y equals 12. All right. To find the x-intercept, okay, we set y equal to 0. 2x plus 0 times y equals 12. 2x equals 12. Divide both sides by 2. X equals 6. I went kind of fast on that. Okay. To get the x-intercept, you make, oops, I did this. I actually wrote this wrong, too, even though it ended up with the same answer. 4 times 0. There we go. You set y equal to 0. Okay. To find the y-intercept, what are we going to set equal to 0? X. 2 times 0 plus 4y equals 12. 4y equals 12. Divide both sides by 4, and you get y equals 3. If x equals 6 and we set y equal to 0, isn't the point here 6, comma 0? And if we did set x equal to 0 and y ends up being 3, this one is going to be 0, comma 3. Those are the 2 points we can do on the graph. 1, 2, 3, 1, 2, 3, 4, 5, 6 there. So 6 across, 0 up gives you the x-intercept. And 0 across 3 up gives you the y-intercept. 1, 2, 3, I should label. And then you draw a line through them, if it was through them. And there's your line. Think you guys could do that on a quiz? Yeah, I think you could too. All right. When we talk about lines, we need to talk about this thing that determines the steepness of a line. OK, yeah. We talk about the slope of a line. OK, the slope is strictly the steepness of a line. The steeper a line is, the bigger the slope is. So which has the greatest slope? That line or that line? A or B? B has a greater slope. Okay? So far, so good. Okay? We define the steepness of a line, otherwise known as the slope, by a formula like this. Now watch, I'll write this out and then we'll see what it actually means. Okay? If we have points x1, y1, like this, that little subscript 1 just means we're calling it x1 and y1. And we have another point called x2 and y2. It's just 2 points on the line. Okay? We say that the slope is the change in y divided by the change in x. Okay? Yeah. Y values, if we're talking about how much something changes in the y value, okay, we call that the rise. Why? Because it can go up or down. That's the rise, vertically. Okay, the rise. If we're saying something goes from on the x-axis, the change in x, we call that the run because it can be running in one direction or the other. It's just the way they call it that. But this is one way to remember how to do the slope. It's the rise over the run. If we have 2 points, the rise is simply one of the points minus the other one. We'll call it y2 minus y1. The run is the difference between the x points, or x2 minus x1. Turns out it doesn't matter which order you put these in. That's also equal to y1 minus y2 divided by x1 minus x2. Turns out it doesn't actually matter. Okay, and let's do an example of that. Okay. Let's do an example. Let's say we had 2 points. Okay? Let's say we had -5 and 1, and 2 and -3. Okay. Before we do anything else, let's just graph this. It's not too hard to graph. Okay? -5 and 1. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. And 1, 1. Right there. That's -5 and 1. 2 and -3. 1, 2, and -1, 2, 3. -1, -2, -3. 2 and 1, 2. 2 and -3 is there. Okay? 2, -3. Let's figure out what the slope is, okay, of this line. I'll draw this line here. Use the orange pen here. Tony, you're looking at me like I'm crazy.
No, I got it. I messed up.
Okay. All right. There we go. All right, so there's our line. OK. I'll stick with the orange pen for right now. If we look at this line, let's do the slope. Okay? By the way, did anybody remember what the letter for slope is? If you've ever done this before? It's really intuitive. It's M. I don't know why it's M. Okay? It doesn't seem to make much sense. But it's M. That means slope. Okay? In typical algebra. Okay? In this case, let's do this. The rise over the run. OK. This is going to be x1, x2. This is going to be, y1, x1 and y1. And this is going to be x2 and y2. OK, so let's do this. y2 minus y1. -3 minus 1 is the rise. -3 minus 1. And the run is x2 minus x1. 2 minus -5. 2 minus -5. What is -3 minus 1? -4. What is 2 minus -5? Sharifa, you can do this one. 7. So what's the slope? -4 over 7. Okay? Let's try this with the switching the numbers, because you could have picked which one was y2 and or x's and x1 and y1 and x2 and y2. So let's do it the other way. Let's say it's going to be y1 minus y2. 1 minus -3 over -5 minus 2. -5 minus 2. What's 1 minus -3? 1 minus -3 is the same as 1 plus 3, which is 4. What is -5 minus 2? -7. Isn't -4/7 the same as 4 -7? It's the same. That negative sign can float up and down here, there, or there. I did. I redid it. -4/7. Yep, it's the same. Okay. All right. What you can do is, if you know the slope, you can actually count it up. It's kind of cool. You can go 4 up and -7 over. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, that point would also be on that line. Pick any point on here, and you can do that. Or you could go 4, negative 7, up 4, over negative 7. That's what I just did. How about down 4, over 7? Coming from here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 ends up on the point as well. All I did was either negative 4, minus 4 meaning not rise but go down, and then over 7, positive, or positive 4, up 4, and negative 7 this way. Okay? All right. Questions on that? We'll do more examples of that. Okay. If we're talking about slope, okay, you can talk about positive slopes and negative slope. This one was negative 4/7 is a negative slope because it's a negative value, right? Negative slopes look like this, or like this, or like this. Positive slopes look like this, or this, or this, because positive slopes are angled up and to the right. Negative slopes are down and to the right, or up and to the left, right? Or this one's, I guess, down and to the left. Okay, positive slopes versus negative slopes. It's easy to tell the difference because you can just look at it and see which way it's slanting. If it's slanting going this way, it's positive. If it's slanting going this way, it's negative. Okay? There are some ones we have to talk about that are specific. And by the way, I think on one of these, I think on my definition, on my definition, I forgot to tell you, x1 and x2 can't be equal to each other. If that was true, let's say this was, instead of 2, negative 3, if it was 5, negative 5, negative 3, y2 minus y1, negative 3 minus 1 divided by negative 5 minus negative 5. Negative 3 minus 1 is negative 4, divided by, what's negative 5 minus negative 5? 0. What's wrong with that? Can't divide by 0. So you can't, the slope is undefined for a line that is perfectly up and down. Is a line that's perfectly up and down a function? Is it? No, because if you did a vertical line, every point fits on that line. So it's not even a function. Okay, so if you have 2 points like that, you can't do the thing. Yeah, Terrence. x1 and x2 can't be equal to the same thing. Yep. They can't be 0. Well, they can't both be 0. They can't both be 5. They can't both be negative 5, etc. So this is an undefined slope. Okay, so if you had a point, let's say this was your axis and this was your line. That's slope m equals undefined. Okay. You can also have slopes. We've got the positives and the negatives. We can have a slope of 0. If a slope of 0 means y2 minus y1 is 0 over 5, let's say, y2 minus y1, if the y values are the same, what does that mean the line looks like? The horizontal line, right? There's your line. Any line that looks like this has a slope of 0. Okay? All right, let's practice. Slope like this. Positive. 0. Right? Yeah, I need a little balance, a little thing. How about this way? Undefined. Okay? Negative. Okay, you got it. All right, pretty straightforward stuff. All right. All right. Anybody still writing this stuff? No. When we talk about lines in formulas, we can actually define a certain type of formula. We can say that there is a slope-intercept form of the equation. Slope-intercept form. Okay, many of you guys will remember this once I write it down. We said that the slope is m. Turns out the x-intercept, you generally use the variable a. The y-intercept, we generally use the variable b. Okay? We can write equations in the following form. Y equals mx plus b. Remember that? Some people are going, oh, I get that. This is called the slope-intercept form. There's the slope. There's the y-intercept. Y doesn't have the x-intercept. Well, you could do it with that way, but then it would look like x equals something not slope plus y a, and we don't do it that way. We just leave it as the slope and the intercept. Those two numbers determine this line. Just like 2 points determine the line, if you know the slope and you know the y-intercept, you can get the line. Okay? We can also, of course, write this f of x equals mx plus b, because f of x is just y. The function of x given by mx plus b is a straight line. Okay? Example, y equals 2/3 x plus 5. What's the slope? 2/3. What's the y-intercept? 5. Watch how easy it is to graph this. Okay? Where's the y-intercept? 5. That means where it hits the y-axis. 1, 2, 3, 4, 5. 4, 3, 2, 1. 5. Okay? I'm going to go up. You'll see why in a sec. What's the slope? 2/3. That means you go up 2 and over 3. Up 2, 1, 2, 3. Up 2, 1, 2, 3. There's your line. See how easy it was to graph that line? I'll do another example. There's too much writing in there. Okay? All right, let's do another example right now. But it's pretty simple to do. With this y equals mx plus b form, very easy to graph these things. Okay? All right. People writing? Sharif, you look like you're writing.
Oh, no.
All right. All right. Slope-intercept form. Here's our example. Find the slope and y-intercept and graph the line. So we've got 3x plus 5y equals 10. Not quite the slope-intercept form yet. Okay? Let's get it in slope-intercept form. We have to solve for y, basically. Okay? Let's do this. I'm going to subtract 3x from both sides, because I'm going to get the y on this side. So minus 3x minus 3x. This gives you 5y equals 10 minus 3x, because you can't combine those. Okay. I'll divide everything by 5 now. If you divide everything by 5, you divide everything by 5. 5, 5, 5. Y equals 10 divided by 5 is 2 minus 3x over 5. Okay? It's still not quite in slope-intercept form. Let's just use our commutative property and move these over. The negative 3/5 x and the positive 2 can be moved. Y equals negative 3/5 x, I'll write it like that, minus or plus 2. What's the slope? Negative 3/5. What's the y-intercept? 2. So you go, here's your graph, and you go 2 for the y-intercept. 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, negative 1, negative 2, negative 3. Negative 1, negative 2, negative 3, we'll say. Start using our slope. Down 3 over 5. So we start here at 0, 2, and we go 1, 2, 3, 1, 2, 3, 4, 5. You don't even need to do another one. You can actually do the line straight through like that. Okay? That was the straightest line all night. Okay? And went through both points. Amazing. Okay? Think we could do that again if we had these? These aren't too bad. You just got to get it in the right form and then pick off the points. You're done. Well, pick off the y-intercept and then do the slope, and you're done. Okay. All right. So let's see. We have that. We have that. We already talked about a horizontal line. Y equals 3. Can we do that in slope-intercept form? Guess what? It's already in slope-intercept form. What's slope? Careful. Let's rewrite it. Y equals 0x plus 3. Slope is 0 because there's no x's up here. Slope has to be 0. Okay, that would be straight line. 1, 2, 3, like that. Not bad, not bad. Let's do, this one's a little weird. This is not a function, remember. X equals 2. Not a function, because there's no y's in there at all. And if we graph this, x equals 1, 2, and x is, for every x, y equals whatever that, or, well, sorry, for every y, x equals 2. So you pick all the y's on here, there's your line. Don't shake your head like that, Nadia. This isn't so bad. If you see it in this form, you just go, oh, look, it's got to be a vertical line. Because it's not even a function. It's got to be a vertical line. All right. Let's skip that example. I'm going to skip that example in the interest of time. Might come back to it later. So that's about it for the graphing part. Well, we might graph a couple other things just to show the graphs. Earlier, I'm going to pick on Dave for a sec. Dave said, hey, that stuff we did at the beginning of class, there's an easier way to do that. Remember all the graphing we did with all the different plugging in all the points and then graphing them both? There's a much easier way to do that. It's just an algebraic method for solving these equations. We're going to do that starting now. Okay? No, this is not bad. Chicken Little over there.
Chuck, do you hear everything?
I hear everything. This is now section 7.3. I have good hearing still. Surprisingly, you know, around here, there's so much noise pollution. I don't know why I can still hear. OK. We can solve some of these equations. Before, we had an equation like this. 2x plus y equals 8. And then another equation, x minus y equals 1. Before, what we would do, when we started class tonight, what we would do with this is we would graph both of those by doing a whole bunch of points for this equation, graphing it, a whole bunch of points for this equation, graphing it, and seeing where the middle was, or seeing if there's any 2 points that happen to be the same. Okay? It's one way of doing this. However, these two equations are called a system of linear equations. A system of linear equations. The nice thing about a system of linear equations is if you have two equations and two things that you don't know, two variables, you can use a little bit of algebra to solve for both x and y without doing any graphing at all. It's pretty straightforward, although there's two different methods for doing this. We'll go over both of them, and I don't care which one you use. Sometimes you'll have to use another one. One or the other. Okay, so for instance, let's pretend we solved this. Does 3, 2 solve both of these equations? X is 3, y is 2. Let's try it. 2 times 3 plus 2 equals 8. 2 times 3 is 6 plus 2, 8 equals 8. Or x minus y equals 1. 3 minus 2 equals 1. 1 equals 1. So there's a solution to these two equations. That number happens to be on both of them. Okay? And believe it or not, we have a way to figure that out. Okay? We could have graphed it. I'll just quickly sketch it for you. Okay? Let's see. How about we do the easy way to do this would be find the x-intercept and y-intercept. If x is 0, that gives us y equals 8. X is 0, y is 8. Just write 8 there. If y is 0, x is 2x equals 8, so x is 4. 4. There's one line. That was the easy way to graph that line. Okay, this one happens to be 2x plus y equals 8. Okay? The other one, if x is 0, y is negative 1. X is 0, y is negative 1. That's 1 point. And if y is 0, x is 1. Y is 0, x is 1. There's the point right there. There's your 2 points. Guess what this point is? This point is 3, 2. 1, 2, 3, 1, 2. Okay? You could graph it this way. If you had one of these fancy graphing calculators, I don't know if you guys have seen these fancy graphing calculators before. This is actually an old one. But those will do that for you. You plug in the 2 equations on the calculator, and it'll go, and it'll actually do the graph for you. And then you can move the little cursor around until it hits that point, and it tells you. Kind of cool. It's one way to do it. Okay? You cannot borrow that calculator. Okay, so that's how that's one way to solve these things. Let's do an actual example that's pretty straightforward using two equations that we can do algebraically. And let me show you what we do. Okay, it's going to be a different set of equations. We're going to use 3x minus y equals negative 2 and 2x plus y equals 7. All right. We're going to use a method called substitution to do this one. Okay? Substitution works like this. Pick one of those equations, okay? Solve for one of the variables, and then use that solution inside the other equation. Okay? Inside the other equation. Okay? So let's look at the bottom one here. Okay? Let's rearrange that so it says y equals something. 2x plus y equals 7. How do we get the 2x on the other side? Subtract it. Minus 2x minus 2x. We're left with y equals 7 minus 2x. This is an equation, right? And it tells us what y equals. Y equals 7 minus 2x. Meaning that if you take everywhere you see y up here, plug in that 7 minus 2x. Why not? If y equals that, can't we just say that every time we see y, we've got that? We can. It says it's equal, so if they're equal, you can always replace one thing with the other, two things that are equal. Okay? 3x minus y equals negative 2. 3x minus, well, every time we see y, we're going to plug in this. 3x minus this. I'm going to do it in parentheses because there's a negative in there. 7 minus 2x equals negative 2. How many variables are left? Just one. Now we just use our regular old algebra to solve for x. And you'll get a number this time. Right? 3x, I'm going to distribute the minus sign through here, because it's really minus 1. 3x minus 7 plus 2x, I'm just minus and a minus, gives me a plus 2x, equals negative 2. I'm going to rewrite this up here. Can we combine the 3x and the 2x? Sure. 5x minus 7 equals negative 2. How do I get rid of the negative 2? Add 7. 5x equals, I'm going to add 7. 7 plus negative 2, or negative 2 plus 7? 5. X equals 1. We divide both sides by 5, and we get x equals 1. You've solved for x. Now if we know what x is, can't we just go back and figure out in any one of these equations what y is? Let's use the one we already solved for. Y equals negative 7 minus 2x. 7 minus 2 times 1. Y equals 7 minus 2, or 5. Y equals 5. Did we just solve that? Sure. We just solved for y equals for those two equations using this thing called substitution. Okay? We can check it too, by the way. Plug in the values we just found out into either one of these. 1 and 5. 3 times 1 minus 5 equals negative 2. 3 minus 5 equals negative 2. Negative 2 equals negative 2. Check. Do you guys write your checks like this? Yeah. For like the first 37 years of my life, I wrote checks like this. You know, and I would always get. It's, my girlfriend at the time said I had a disability. She's like, it's a disability. But I always, you know, people are always like, put a check marks in the box, and this is the easy way to do it, right? I would have the hardest time. I'd be like, right? And it would always look funny. My checks would always look funny, and I'd notice all these other people's, like, whatever, they check, and I'd be like, wow, they're so nice checks, such nice check marks. Mine were never nice like that. I don't know why. Now I know why. I relearned. I overcame my disability. Now I can return it. All right. OK, so we've checked that. OK. So that is one way to do it, the substitution method. Solve for one, substitute in. You can always do it that way. Some equations are easier solved using another method. In fact, I'd argue this one was easier solved using a different method. I'm going to leave the answers up here so we can check it in a minute. There's another method called the elimination method. The elimination method says get rid of one of those variables by doing like doing one of these, or I should say, doing some operation on these two equations together to get rid of it. Let me use this exact one as an example. This is called elimination. What if I was to add all the parts of these to each other, the ones that add together? Like, in other words, I'm going to do the 3 and the 2, x, and the negative y and the y, and the negative 2 and the 7. What's going to end up to the y's in this case? It's going to be eliminated. That's why it's called the elimination method. 3x plus 2x, 5x. Y and negative y, 0, right? Equals 7 and negative 2, 5. Now we've just got 5x equals 5. Divide both sides by 5, and we get x equals 1, which is exactly what we had there. That was way easier. In this case, it was way easier. Sometimes it's not way easier. Sometimes it's like, because it turns out in this case it was easy. Oh, sorry. Sorry. Here, I'll add it again. 5x equals 5. Divide both sides by 5. X equals 1. And then now you're going to plug in x into any one of these, and you're going to still get 5, just like we did before for y. Okay? Sometimes it'll be harder. It turned out that adding this immediately got rid of one of these variables. What if this had been 6y? Could you have done that? No, because then you would have added it, and you still would have been left with something else. You could multiply the whole top one by 6. If we did, you can take this and multiply the whole thing by 6. 3x minus y equals negative 2. Every part by 6. 18x minus 6y equals negative 12. How did I get 6?
Yeah, where'd you get 6 from?
Well, I'm trying to get rid of this 6. So now what happened? Now look what happens. If I did this whole thing multiplied by 6, then if I rewrite this one, 2x plus 6y equals 7, can't I then add them together and get rid of the y? Yeah. So you could have done that. Sometimes, though, right, it might be like 5y. Well, now what do? You know? Now you have to do either the substitution method, or you could multiply this one by 2 and this one by negative 3. Because look what would happen to the x's. This one by 2. 6x minus 10y equals 4, or negative 4. This one by 2. This one by negative 3. Negative 3 times 2x, negative 6x. Negative 3 times 6 plus minus 18x. Negative 7 times 3, negative 21. Thank you. A y. Like that. And then can I add these together and the x's go away? Sure. So that's that would be the hardest one I might give you. In fact, I might give you that one on the quiz in 2 weeks. Okay? Not exactly that one.
So you have to decide which one you want to get rid of.
You get to decide which one, and you have to decide which one you get rid of, right? So you could have done this. What if you'd multiplied this one by 3, and this one, not 3, 6. This one by 6, and this one by 5. This would have been negative 30, and this would have been positive 30, and the y's would have gone away. Okay? All right. Let's do another one that's not quite so hard. Okay, these are ones that I'm just getting into, like, these are the kind of the harder one material. Let's do this one. 4x plus 2y equals 4, and negative x plus y equals 5. Can anyone tell me what something I can multiply by to make this one of these things drop out? Yeah. If I multiply by 4, Orlando says, no, not negative 4.
No, I didn't say.
Oh, right. Sorry. Or negative 2. You're right. If we did 4, if we multiplied this one by 4, the x's would drop out because you'd get negative 4x and you'd have 4x when you added them together. If you did this one times 2, not 2, negative 2, then this would become negative 2y, and the positive 2y would cancel out. Okay? You could have multiplied this one by 1/4, because this would have dropped, whatever, but you wouldn't. You wouldn't want to do it that way. Good. So the first one I heard was 4. Let's do the bottom one by 4. So we're going to do negative x times 4 is negative 4x. Y times 4 is plus 4y. 5 times 4 is 20. And then I'm going to take this one and add it to it. So I'm going to add 4x plus 2y equals 4. And these are going to go away, and I'm going to be left with 6y equals 24. And a lot of times these will come out nice and even. Not always. A lot of times they'll come out nice and even like this. If I divide by both sides by 6, y equals 4. You're only half done, though. Well, you're like 3/4 done. What you have to do now is you have to plug 4 back into any one of those equations, and you should get the right answer. 4 goes into, let's say, this one. 4x plus 2 times 4 equals 4. 4x plus 8 equals 4. Subtract 8 from both sides, and you get 4x equals negative 4, or x equals negative 1. Your answer is y equals 4, x equals negative 1. How do you check it? You plug both into one of those equations. Let's plug it into this one. Negative 1 plus 4 equals 5. 1 plus 4, 5 equals 5. And non-disabled Chris can do a little check. Right? OK? 5 equals 5. That's how you check those. OK, so we did that. Let's do another elimination. I'll give you a harder one. Anybody still writing this one? No? Amy, it's not that bad. Amy, stop listening to Nadia. All right. OK. 2x equals 7y minus 17. 2x equals 7y minus 17. And 5y, and be careful with this one, equals 17 minus 3x. I don't think they're lined up right. Let's make sure we line them up right. Let's get all the x's and y's on the left. For the top one, here's how I would do it, by the way. I would rewrite it down here. 2x equals 7y minus 17. And I'd say, fine, I want to get the 7y over here. What do I do? Subtract 7y. I'm left with 2x minus 7y equals negative 17. Okay? This one, I have to do the same thing. It's already written there. I could just do it right here. let's get the negative 3x to the other side. What do I do? Add 3x plus 3x plus 3x, whoops, x. 3x plus 5y equals positive 17. And I'll rewrite that down here. 3x plus 5y equals 17. Everybody's lined up, right? Now we've got this issue of we have to do either substitution or elimination. Let's do elimination. We do have to do this fancy multiply to get something together. What's wrong?
Nothing.
No, go ahead. How do we now do this? Is that your question?
Sure.
All right. We've got to get one of these variables such that when you add these two together, it drops out. Okay? There aren't any easy choices in this one, but it's not too bad. Dave, what do you think on this one?
Get rid of the x's because you're not denominators of this one.
Get rid of the x's. Good idea. How are we going to do that?
Negative 3 positive 2.
OK, so what Dave's saying is, let's make it so this is 6x and negative 6x. One of these ones is going to be negative 6x. One of them is going to be 6x. Because we can easily multiply them both to make 6. Right? Because 2 and 3 have a common factor, or are common factors of 6. Right? Or are factors of 6. So I think you said negative 3 to the top? All right. Let's multiply the top one by negative 3. And let's multiply the bottom one by 2. So the top one, you get negative 3 times 2x is negative 6x. Negative 3 times negative 7y is positive 21y. And negative 3 times negative 17 is positive 41. Is that right? 51, thank you. 51. Okay. Multiply this one by 2. 2 times 3x is 6x. That's good. 2 times 5y is 10y. 2 times 17 is also 51.
34.
Add the two together. 34, did I do something wrong? Oh, thank you. It's not 51. I did do something wrong. 2 times 17 is 34. Thank you. I was thinking 3 again. All right. So when we add these together, 0 x's. So we get 31y equals 85. Yeah. Oh boy, this is going to be ugly. Divide both sides by 31. You get y equals 85 divided by 31. That is ugly. Right? But you could now plug in 85 31s into here, and you could solve for x that way. Okay? Or we could do the same thing here where we, instead of getting the x's by themselves, we get the y's by themselves. Like you'd multiply, let's see, we had these here. We would multiply this one by negative 7 and this one by, did I write those down wrong? Yeah, positive 5. This one, here we go. This one by 5 and this one by 7. That would do. You could redo it. So we've got the y. Let me just redo this real quick here. Okay? Instead of getting rid of the x, let's get rid of the y. Well, for this one we'd multiply, because it's got to get 35, we'd multiply this one by 5, and multiply this one by 7. Because we want negative 35 and 35. Okay? So we would be left with 10x minus 35y equals 5 times 17. 5, 3, 85. Okay? And then 7 times 3x is 21x. And then this is going to be 7 times 5, 35y, which is good, equals, and now it's going to be 7 times 17, 17 times 7, 9, 4, 119. Right? So it's going to be, those are going to cancel, it's going to be 31x equals 119, or x equals, divide both sides by 31, 119 over 31. Okay?
Isn't that a negative 85?
Ah, what did I do? Where's the negative 85? 5. Yes, thank you. So in that case, it's not going to be. Wait, what did I do wrong here? I forgot to add it all. I forgot to add it all together, didn't I? Oh, negative 119. Like that? Sorry, like that. No? Hold on.
Multiply both by positive, so it would still be negative 85 and positive 100.
Thank you. Positive 119. There we go. All right, now I got it that way. So it's still 31x over here, and this one is 119 minus 85, which is what?
34.
34, thank you. So now we've got x equals 34 divided by 31. That makes sense? All right, so we used elimination twice, and we didn't have to then plug anything back in. And we got 34 31s and 85 31s, for example. Okay? All right. Sorry, that was probably like the hardest one we would do. Okay? But you could use elimination twice, and you could do it. OK. A couple more things, and then we're done with this stuff. All right. How many different ways can two lines intersect each other? There's a line. There's where one way it can intersect. Okay. What if we had two lines that looked like this? Line number 1 and line number 2. Right? Right on top of each other. Is there any other way? Let's pretend that's line number 1 by itself. Line number 2. Do those ever cross? No. Those are parallel, right? Or they're on top of each other. Okay? In this case, if we have this line and this line, we end up with one of those expressions where the answer doesn't make sense. Right? If we have them on top of each other, we end up with an answer where everything makes sense, because every point is the same. In this case, no point's the same. The other case, every point is the same. Okay? So let's look at something like that. Okay? 2x plus 14y equals 18. 3x plus 21y equals 27. Here's our system of equations. Okay? Let's see. If we did 3 times this one times negative 2 times this one, wouldn't the x's go away? Okay, so we'll do 3 times this and negative 2 times this one. 3 times this. 6x plus, let's see, 42 y equals 18 times 3 is, 8 times 3 is 54. All right. Let's do negative 2x times, or negative 2 times this one. Negative 6x plus negative 2 times 21. Negative 42y. And then negative 2 times 27 is 54. Negative 54? OK, what happens when we add them? 6x and 0 plus, uh-oh. The y's drop out too. Everybody drops out, right? We get 0 equals 0. Remember what happens when you get an equation that you've solved and this side equals this side and it is a correct equation? That means that you've got a situation where the lines are right on top of each other. Right on top of each other. Okay. The what?
You just keep giving us those.
I do keep giving you those problems because you got to know these things. I don't know why, but you do. OK? So in this case, it's true regardless of the value of y, meaning there's infinitely many solutions, meaning you plug in whatever you want, x and y, into any of these, and it will always be the case that you've always got the right answer. OK? All right. Here's another one. 4x plus 6y equals 12. 4x plus 6y equals 12. 4x plus 6y equals 12. And 6x plus 9y equals 12. All right. let's do a slightly more difficult multiplication for this one. Let's just multiply the top equation by 1.5, or negative 1.5, negative 3 over 2. Why? Because negative 1.5 times 4 is negative 6. I knew that because I looked on my sheet, but I wouldn't necessarily make you figure that out. But in the interest of time, if we do that, watch what happens. Negative 3 halves times 4 is going to be 12 divided by 2 is negative 6x. So far, so good. Negative 3 divided by 2. 18 divided by 2 is 9, so negative 9. Negative 9y equals 18. Okay, because negative 3 halves times 12, 18. Okay, if we tried to add 6x plus 9y equals 12 to this, 0 plus 0 equals 12. Is that even a true statement? No. This is one of the ones where you've got parallel lines. Okay, no solution. Okay. All right. Let's do this. I'm gonna spare you. I'm gonna give you a break now, and then when we come back, we'll talk about chickens and pigs. Yep, word problems. One more chicken and pig problem, and then we'll do it. With the feet. Yeah. All right, come back at 10 after. So I kind of lied to you. We're going to do chickens and pigs in a minute, but the first one I want to do, I thought about this over the break, and I said, well, I keep skipping some of the word problems, and that's the hardest stuff on the final, so we better do a few more word problems. I know you don't like word problems, that's why we have to do them. All right? That's why we have to do them. Why is what?
Why is the final word problem?
Because these are the kinds of things you see in real life. How often do you see like x plus y equals 2? You see like real life problems. No, you don't. Well, okay. Look at this problem. Anybody ever want to own a business?
Want to or have?
Want to or have. Okay, so some of you guys want to own a business, right? If you're a business owner, word problems are like how you figure out if you're going to make money. Let me show you an example. I'm going to have to edit that out. Let me show you an example. Okay. Okay. Pretend you make wheelchairs. Okay. Let's just pretend you make wheelchairs. In fact, I saw the coolest wheelchair ever once. It was a wheelchair. It obviously had the 4 wheels back in front, and then it was electric, right? And then you could push a button. You know, it's like wheelchair. People who are in wheelchairs are like here all the time, right? And they're talking to people, and other people are up here talking. It's always this relationship where you're talking up like this. It does this. The two back wheels go on top. Then it becomes like a Segway, where there's like 2 wheels on the top, 2 wheels on the bottom, and the person is this high. And he's still sitting in the chair, but he's this high. It's awesome. It was so cool looking. So if you think there's like no more stuff to do in wheelchairs, that was cool. So what's that?
Why were you selling wheelchairs?
No, I saw somebody. I actually went to a. Long story short, I was at a robotics competition when it was when I was teaching high school that I was like the robotics mentor or whatever. That's how nerdy I am. I know, I'm a nerd. And this guy was a representative for Rhode Island in the Senate or something, and he had one of these wheelchairs. And he did the best part about it was he was seated down low in the wheelchair doing this whole speech. And finally, and it was all about how great the robotics were in wheelchairs and this and that. And he goes, and take a look at this wheelchair. Boop. It was so cool. Everybody's like, whoa, and we all cheered. And it was cool. Yeah. It was cool. So anyway, if you want to, just whistling. Okay. So this is an example of if you're owning your own business, you better figure out something like this. You manufacture wheelchairs. It costs you $500,000 to build your plant, your wheelchair plant. Okay? Fixed cost of $500,000. That's what the K is for. And it costs you $400 to make a wheelchair. Okay? That's the marginal cost. That's what it's called. It's not an economics class, but that's what that's called. The marginal cost is $400. In other words, $400 per wheelchair. You can sell wheelchairs for $600 each. By the way, I looked into it to see how much those wheelchairs were. $50,000, I think. But think about it. That's like a super high-priced car. right? But like this is like your life if you're in a wheelchair. Anyway, I think it might have been worth it, but whatever. It's still pretty expensive. Okay, question is, how many wheelchairs do you have to sell before you break even? Okay, let's figure it out. Somebody already has. Spoiler alert. Okay, let's figure it out. So what you first want to do for a question like this, like I've already done, circle all the big items in here, okay? And then circle what you're trying to find. Okay? So you say, look, the break-even point, I know it costs $500,000 for my plant, and then $400 per chair, and I can sell chairs for $600. So what we can do is we can write a couple functions. Let's do a function of x. This is, instead of saying f of x, we're just going to call it c of x. In other words, the cost per x, in this case, the cost of each wheelchair for us. What's a wheelchair cost? It costs $500,000, actually it's for x number of wheelchairs, plus what? 400 wheelchairs times x. Because for the number of wheelchairs you make, you have to pay $500,000 off the top. And then you got $400 per chair times x for each x left. Okay? That's your cost. How about your revenue? R of x. This is actually really easy. For every wheelchair you sell, how much do you get? No, 600. You don't get the 200 because you sell it, somebody hands you 600 bucks. Okay? 600 times x, right? Times the number of chairs that you sell. Do we have two equations with two unknowns? X and this, in this case, we'll just make it both y. Do we know how to solve these? The answer is yes. You just did. We just did, right? Okay. Okay. For all you knuckleheads. All right. I'm running out of space. I will erase the top part here and just put this up here. OK. So we've got the two equations here, which are y equals 500,000 plus 400x for our cost. And then we've got y equals 600x for our revenue. And we're going to try to find out what y and x equal to make this work out. It's basically the 2 points where those two lines cross each other. Okay? All right. Well, this is actually a pretty easy one. What would be easier to do here, the substitution method or the elimination method? Why substitution? I'll ask again, why substitution? There you go. OK? Ben says y is already set. Right? If we already know what y is, can't everywhere we see a y up here, we just plug in this? That's the substitution method. Everywhere we see y, we plug in 600x. 600x equals 500,000 plus 400x. Now what? Subtract 400x. Yeah. Subtract 400x minus 400x, and we're left with 200x equals 500,000. Now what? Divide by 200. Okay. It turns out that 200 goes into 500,000 2,500 times. How many chairs do you have to sell in order to break even? 2,500. It's a lot of wheelchairs, right? Well, it depends. You know, I'm sure some company sells 2,500 wheelchairs a year. Okay, but that's how you would have to do that. Okay, and what is the revenue off of 2,500 chairs? 25 times 600, right? And that's the same cost that you have, right? So by the way, this is only break even. You don't make 1 penny until your 2,501st chair, right? Well, but okay. So bottom line here. Here's the final, like the bottom line of all this. And I mean, Terrence, you're absolutely right. You say that's messed up because businesses sometimes, well, businesses have to think about this stuff. I mean, you have to think about this stuff. You have to say, whoa, I better have enough money in the bank now to cover myself until I sell at least 2,500 chairs, and then I'm only making, $600 a chair after that, right? So, and then I got, you got to figure all that out. Yeah, Rennie.
Are we gonna get more stuff if we don't do all that equation? Because
Well,
when I looked at it, it was you have to pay 400
yeah.
to make 600. So I just subtracted the 4 by 600 and divided by.
You're doing the same thing. Write out as much as you can. I mean, write out, like if you thought that in your head, write that out. I'm fine with that. You write that out. And then divide it. But if you do it wrong, I can only give you so many points because I can't necessarily figure out where you went wrong. It's the only problem. We did the, that's called the substitution method.
I think, is that the elimination method?
Oh.
What you did?
I just subtracted the amount that it cost to sell by the amount it cost.
Yeah, well, you did the same thing.
Yes.
I mean, he did the same thing. If you wanted to do the elimination method, multiply this one by -1, and then do that, right? You'd get 0 equals 500,000 minus 200. And then you add 200, divide by 500,000, or divide by 200, and you're good. So you could do the elimination method if you wanted to. But that's the bottom line is, this is why they ask you these word problems. Because someday, some of you guys are going to actually use things where you have to do some of this math. And unless you want to hire an accountant for $500 an hour to do it, or you could hire Treve for $500 an hour to do it, right? You come on. Yeah. OK. All right. I promised you chickens and pigs. Let's talk about chickens and pigs. OK. Last week, we talked about chickens and pigs. And we said Farmer Smith has a farm with chickens and pigs. And he has 20 animals. 20 animals. OK? And he has 64 feet. Remember that? OK. And there's chickens and pigs. And the question is, how many chickens and how many pigs? And last week, and this is the kind of thing you might need to do on your quiz tomorrow, hint, hint, we did either a table or we guessed and checked or whatever, right? OK? There's an easier way to do this using algebra. OK? Let's call chickens C and pigs L. No, P. OK? All right? We'll call chickens C and pigs P. If there's 20 animals, what do you know about the relationship between C and P? There you go, Sharif. What is it? C plus P equals 20. So far, so good. What do you know about chickens and their feet versus pigs and their feet? I was about to write it this way. Yep. 2 times the number of chicken feet, because 2 chickens have 2 feet, and 4 times the number of pigs' feet gives you the number of pigs' feet. Right? What happens, can we make a relationship of those with the 64? 2c plus 4p equals 64. Does this look like a set of equations? Sure does. Which way do you want to solve it? Elimination or substitution? Let's do both. I heard elimination first, so let's do elimination first. If we're going to eliminate one of those, which one do you want to eliminate?
4.
The 4? How about a C or a P?
Oh, the C, my
OK. What are you going to multiply by what to get rid of that, to get it so that you can get rid of that C? Careful. Multiply the top by -2. -2 times the top. -2 times C is -2C. -2 times P, -2P. -2 times 20 is -40. Can I add these two together now? The C's go away. We get 4P minus 2P is 2P. 64 minus 40, 24. Divide both sides by 2. And what do you get? Number of pigs is 12. Right? If the number of pigs is 12, then what does that mean the number of chicks is? Chickens. C plus 12 equals 20. Subtract 12 from both sides. And chickens equals 8. That was a lot easier than doing the guess and check or drawing out all the chickens or whatever. It was not as fun. It's not as fun. Okay? Questions on the elimination method? I won't erase it yet. In fact, I'll leave it there. We'll do the substitution method. Actually, I'll do it right over here. Substitution method. Solve one of these for one of the variables. Let's do the top one. What do you want to solve it for? P or C? C. So what do I have to do to this to get rid of the C? Minus P. C equals 20 minus P. Everywhere I see a C, I plug in 20 minus P into this one. 2 times 20 minus P plus 4P equals 64. You got to distribute the 2 through. 40 minus 2P plus 4P equals 64. 40 minus 2P plus 4P, we've got 40 plus 2P equals 64. Subtract 40 from both sides. 2P equals 24. P equals 12, because I divided by 2. Same exact thing.
What method was that again?
That was called the substitution method, because you solve for one of them and then substitute that answer into the other equation.
My biggest issue with
Yeah.
word problems is understanding what needs to be done from the words.
Yeah, that's a very good question. So Rolando said, my biggest problem with word problems is understanding what to do with the words, right? Yeah, that is the hardest part. The way to get around that is to do lots of practice. It's also to do your steps. Like when I wrote down the word problem for the wheelchairs, I circled all the numbers, because those you're going to have to use. Well, in some cases you might not, because sometimes they trick you by adding more numbers. But I really won't do that. Maybe in one problem, but that's it. Not tomorrow anyway, and not on the next quiz, but maybe on the final they might. But the point is that you circle all those, then you circle what it's asking, because it really says a question. It says how many feet does a chicken have, or how many chickens are there, rather, or whatever, right? You know. And so you say, oh, okay, I want that. Then you got to work backwards, maybe. You got to use all those problem-solving steps. So it is hard, but it does get better with practice. I will tell you that. I'll tell you that. OK. So we are done with the new learning stuff. Now, it's 8:30. Here's what I want to do. If you have not gotten, if you didn't either print out or have, well, if you don't have a copy of the practice quiz, you do not have it. It's coming around. I'm handing that around now. I gave it to somebody earlier. Don't take two. Like in other words, don't take another if I gave them to you earlier. Okay. As with the last quiz last week, I don't know if you noticed, but the questions were very, very similar to the practice that were on the real quiz, right? Aaron, I know, practiced the practice quiz and did great on the quiz because I saw him practice and he came on Thursday night and practiced it, right? Same with a lot of you guys. So the same thing is going to be true with this one. What we look over in the next few minutes is going to be very, very similar. Okay? So here's how I want to do it. I'm going to pull up the quiz. Why don't we do this? Why don't we spend 15 minutes just working on it? And by the way, if you think you're ready for the quiz tomorrow, see you later. You can take off. But if you want to get some review on the quiz, please stick around. 15 minutes, take the quiz, look at what the problems. You don't even have to solve all of them, but if you go, oh, I know how to do that one, skip it. I don't know how to do this one. Let me try this one. Right? Okay. And while we're doing that, I'll set up the computer so I can put it up on the screen and you can see it. OK, so we can do a couple different things. I can start going over whatever problems you want. And those of you can keep working if I'm not going over a problem you want me to, or if I'm going over one you already know. or I can just shut up and answer questions individually. Or we could go through the whole test. What do you want to do? The whole thing? All right. If you don't want, if we're on a problem that you already know how to do, then don't worry. Like don't pay attention. If you, I'll have to go kind of quickly. But what I do suggest is going back and doing these on your own, even though we're going kind of quickly on it. Okay. Professor Geometry, want me to go over that one?
Yes.
Okay. All right. This one you can do using algebra, the way we just did with the chickens and pigs, or you can use some other method, like for instance, guess and check, or do a table, right? I like kind of a combination of guess and check and a table, because you can say, look, you know the squares and triangles. You have 15 squares and triangles, right? So you have to, the two numbers you have to add up to 15. Pick one somewhere in the middle, right? So pick how many triangles? Pick somewhere in the middle of 15. How many? 7. So 7 triangles. I'm going to do a little table. Triangles and squares, okay? And then the sides. Okay, so if I have 7 triangles, how many squares do I have to have if there's 15 total?
8.
Is it 15? Yeah, 8. Okay, how many sides do I have? 7 times 3 is 21, plus 8 times 4. 8 times 4 is 28. No, 32. 32 plus 21 is? 32 plus 21 is 53. Right? Okay. So look, do we have enough sides?
No.
We need to add either triangles or squares.
Triangle.
If we had just try it. 8 triangles, 7 squares. 8 times 3 is 24. 7 times 4 is 28. 12, 52. Are we going the right direction?
No.
No. So we shouldn't have added a triangle. We should have
We should have
added a square. So let's say 9 and 6. 6 times 3 is 18. 9 times 4 is 36. So we have 6 times, it's 14, 54. Did we go in the right way? 53 to 54. Okay. How many were we trying to get total?
56.
If we added 1 square, we got 1 more side total. So we need to get how many more sides total?
2 more.
So how many more squares are we going to add? 11 and
4.
4. 4 times 3 is 12. 11 times 4 is 44. 4, 6, 56. Did we get the answer? That's it. So you see how you did that? We guessed and checked, and then we started going up and up and up.
I was trying to do an equation. I got down to 11, but then it was, I guess what happened with mine was figuring out which ones was which.
Okay. So what was your equation?
Um,
Should have had 2.
huh?
What were your equations?
I made 15, and then in parentheses, 4s plus 3t.
Equals 15? Did you say that?
No, equals 56.
Oh yeah, you're right. Equals 56.
So, but I had the.
And then what was the 15?
I had the 4, 2, and the 3 in parentheses, and I had the 15 outside of that. And I was trying to do the for the district.
Yeah. You can't do it that way. You do need 2 equations. You try to do it with 1. You do need 2 equations, at least to start out with. You might be able to mangle it into 1 equation eventually, but let's just try this. How many squares plus how many triangles do we have?
How many squares?
15. Now we have 2 equations. We have a set of equations. Now you're going to do that, right? You can do it either substitution or elimination if you wanted. Let's do elimination. Multiply this one by -3. That's going to be -3s plus negative 3t equals negative 45.
All right.
Add this up, we get 4s minus 3s is s. 56 minus 45, 11. There's your number of squares. I wanted to get rid of the t, so I multiplied this whole thing by negative 3 so that 3t plus minus 3t equals 0t.
So could you have gone negative 4?
You certainly could have. Yep, negative 4 would have gotten rid of the s's. It would have been left, and you would have ended up with t equals 4. All right, let's move on. You will see a problem you have to do some other way to solve, but it will not be a problem like that. Okay. Evaluate the algebraic expressions. If I say this and plug in this, it's not too hard. You just have to do the algebra right. You have to do the arithmetic right, really. 3 times negative 3 squared minus 2 times negative 3 plus 5. Negative 3 times negative 3 is what? 9. It's in parentheses because the x squared is the thing you do first. 9 times 3 is 27. Oops. Negative 2 times negative 3. 6 plus 5. 27 plus 11 equals 38. Okay? Okay, let's look at this one. P is 4, so plug in 4. 12 divided by 4 minus, in parentheses, 4 minus 2 squared. What's 12 divided by 4? 3. What's 4 minus 2? What's 2 squared? 3 minus 4 equals negative 1. So far, so good?
No.
No? Why?
I just be getting the stuff I need to do confused. Like every time
Yeah.
I deal with fractions, I'm always thrown off. So I know I just need to do more of them so I can get the hang of it.
I think you're right.
Please don't erase it.
I won't. I'll work on this one, though. I'll just work on this one. This is a matter of being able to distribute. Distribute the 3 through. 3 times 4 is 12x squared. Because you can't do anything with the x squared. 3 times negative 2x is negative 6x. Minus 5 times 2. Negative 10x. Minus 5 times 7. Negative 35. Is there anything we can combine here? The x's. 12x squared minus 6x minus 10x is how many x's? Minus 16 x's minus 35, and that's all you can do.
You said that's all you can do?
Yeah, you can't combine anything. Can you combine an x squared term with an x term?
No.
Can you combine an x term with a non-x term? No. By the way, Terrence, this is all on the back. On the last few pages, the answers are there
I'm
too.
trying to do it without looking at it first and then
Okay.
keep myself off.
Okay. Can I move on, though?
Yes, you can.
All right. Anybody else questions on this one, this page? Okay. Oh, you just want to see my butt jiggle.
What? I hope that's not on tape.
I'm in trouble. Oh no, now I'm in trouble. Now I'm in trouble. All right, this is such an easy problem, you're probably overthinking it. Anybody who got this wrong? Term 1, 7x cubed. What's the second term?
I had to look.
Negative 5x squared. What's the next term? That's all a term is. So you got to know what a term is. That's a term, and that's a term with the negative. I know, and that's a term, and that's a term. So negative, and then 2x, and then negative 6. This is going to be the easiest problem on the entire quiz.
Oh, yeah.
Right? 8 points. I might not make it 8 points. We'll see.
Make it 8 points.
90 points? No.
I'll stop taking the test.
All right. Solve the linear. By the way, you guys who are leaving, you guys, I think one of the trickier ones was the, if you don't remember to cross multiply for this.
Yeah, I did. The other way just still came out, and then I looked
Hey,
at it. Oh, cross multiply.
you can do it the other way if you want. Okay, let me just do, let's go back up to this
Keeping
one.
the test, Chris, or do you want them
You can keep them. Yep, you're good. Okay. Solve the linear equation and check the solution. We've been doing this all night, right? 3x minus 5, we're solving for x. Negative 11. What do we do? Andrew, what do we do? Add 5. Good. 3x minus equals negative 6. Then what? Divide by 3. X equals negative 2. Done. You got to get over the word problem part. Practice them and circle and circle and, you know, it's not your kryptonite.
exponents? Not exponents. What is that? What's that little weird ass symbol?
The radical, square root.
Square root.
Yeah, what about them? All right. All right. Well, we won't see too many more of those. Okay. I was just mentioning this to the guys who are leaving. This problem is, there's lots of ways to solve it. The easiest is to cross multiply because it's a ratio, and you know that 2x times 10 has to equal 5 times 3.
5 times 6.
Thank you. 5 times 6. 5 times 6. Yep. Andrew, you good? Sorry, Andrew's good. Sorry. Rob, are you good? All right. I'll see you tomorrow. OK, so then this just becomes 20x equals 30. And then what?
20x 30.
Yeah.
Take away the divide by 20.
Divide by 20. And you're left with x equals 30 over 20, which 3 over 2. I know it's so easy when I do it. That's what you have to. That's why you have to practice these things, because it gets a lot easier with time. Dominic, that one make sense to you? Now it does. Cross multiply is when you see a ratio like this, you just cross multiply. Okay. Yeah. You want to try another one? Okay. Let's try this. 5 over x equals 2. It's exactly the same. What's 2 in fraction form? So what do? We cross multiply. 5 times 1 equals 2 times x. X equals 5 halves. Good? Okay. Want to do another one? 1 over x equals 5 over 7. I'll answer this without doing anything. 7/5. When you take 1 over something, you flip it. That means that 1 over something equals 5/7. In other words, 1 over 7/5 equals 5/7 because you flip what's on them. You don't like that? No. All right. All right, we're moving on. And we're walking. Number 7. Pamela, now, this one you can do a couple different ways. I like the algebra way myself. Good. I'm glad you got it right. Pamela bought it. This is the word problem you hate. I'm glad you got it right. OK. Pamela bought a new car for $35,000. That's a pretty expensive car. Or maybe it isn't these days. I haven't bought a car in a long time. 35,000, is that a lot for a car? Still seems like a lot. A lot for a car. Okay. Is it average? Ugh. I couldn't buy, yeah. I've never bought a new car. I never want to. Too expensive. Okay, new car, $35,000. Its value is decreasing per year. This is where you say, look, per year means something here. That means $4,200 times the number of years is going to tell you how much it's decreasing every year, right? After how many years will its value be 24,600? You could keep subtracting, but let's do it using algebra. I know. Let's do it using algebra. New car for $35,000. 35,000 minus 2,400 times the number of years equals 24,600, because that's what you're trying to find out.
Wait a second.
Thank you. My dyslexia, 4,200 minus 4,200x equals 24,600. Now, I will tell you, going from the word problem to the algebra does take some time. But this is where you're going, it's decreasing. Well, you better have a minus sign in there, you know? Like, that's the kind of thing you can think of. You go, oh yeah, I got to have a minus sign. And what am I trying to do? I'm saying every year I go down by 2,400 or 4,200. 4,200 x. X is the number of years. Okay, to solve this, add 4,200x to both sides. 35,000 equals 4,200x plus 24,600. And then subtract 24,600 from both sides. And you get, what is this? 0, 0, 4, 10,400 and $400 equals 4,200x. Divide by 4,200. And you get about 2.5 years. 2.48 or something?
2.47 is actually.
And then what's it say? Give the answer to the nearest half year. All right. Reading instructions 101.
You ever get those tests in high school where they're like,
Yes.
where you actually read the
do the whole
directions
test
and it's
and
like,
then you realize, oh,
do
you didn't
the
get it.
last question and you're done with the test.
I had a friend of mine, a chemistry teacher, on the first week of class, she does one lab exercise with the students, and it's got lots of instructions on it. It's not like that. I mean, they really do have to follow all the instructions to get the right formulas and whatever. And then she grades them all. And the grades are like, A through D, right? She can use those grades at the end of the year, and they're almost identical to how the student does at the end of the year. Because it's all about following instructions. Like chemistry's like half of it's about following instructions. And she's like, you know what? The first day I can tell what you're all going to get this year. Yeah. Okay. No, don't go. You got to at least look at these. There's only a couple more. Solve the inequality. You'll make it. You don't. You can go if you want to, but just saying. 3x plus 7 is greater than or equal to 16. Just solve it as an equals, as if it was equals. Subtract 7. 3x is greater than or equal to 16 minus 7 is 9. Right? And divide by 3. X is greater than or equal to 3. And then on here, 1, 2, 3, circle that way. Is it going to be filled in or not?
Filled.
Why? Because it's greater than or equal to filled. Okay? Yeah, go ahead.
If it's circled in, it's less than.
No. If it's circled in, it's got the little equals sign on there.
Okay, and if it's not circled in, but the circled in, there is no line.
It would be like greater than, yeah. Now, what's the one thing that screws people up on these?
Switching from the negative.
Yeah, if this had been negative 3x plus 7, you would have gotten negative 3x is greater than or equal to 9. And then what would you have gotten?
Negative, you got x is less
You would have
than or greater than.
you would have divided by negative 3. And because you divided by a negative 3, you have to switch the sign, less than or greater than. So it's going to be, this would be x is less than or equal to negative 3. Okay? Don't forget to do that. I can almost guarantee you that'll be on there tomorrow. Sorry. I almost didn't.
So
Negative 3.
the only time it's filled in is when it's equal. No.
Yes.
Okay. And then if it don't have a line, it's not filled in.
Yes.
Got it.
Okay. Okay. Can I erase it now? All right. All right. I think there's only one more page, right? Okay. Multiply. This is just a simple what?
FOIL?
FOIL problem. First, outer, inner, last, or first, outside, inside, last. The first here, 6x squared. The outer, minus 8x. The inner, minus 33x. And the last, minus 44. And then you add the ones that you can, which are these two. 6x squared minus 41x minus 44. That's it.
I got them, bro. We had a lot of those on the homework.
Yeah, a lot of those in the homework. So, anybody still working on the homework?
I got one problem.
You'll do them. All right.
Maybe forget about math for a second.
Oh, no. Any questions on this one, FOIL? Okay. Factoring. Is this an online class?
No.
A real class. Oh, the one with the Department of State person. All right, factor this. Just do your little parentheses first. I'll give you a point if you put the parentheses. Just the parentheses. Because at least you know what you're trying to do. You know, at least you're saying, I get what factoring is. You might not. You might have a brain craziness and that's it. But okay, put the x's in there. That'll probably get you a point.
Yeah.
Right?
You're feeling good, aren't you?
You're feeling good now. How do you do the rest of this? You figure out what factors go into negative 28. You start writing them down. Negative 1 and 28. 1 and negative 28. 4 and negative 7. Negative 4 and 7. 14 and negative 2. Negative 14 and 2. And then you say, all right, these guys have to add up to be negative 3. Which one of these adds up to be negative 3?
4 and 7.
Which one? There's two 4s and 7s.
Oh, 4 and negative 7.
4 and negative 7. 4, negative 7. You're done.
You have a lot of those on the homework too.
Yeah, there's lots of homework, and there's one on the quiz tomorrow.
Correct me if I'm wrong.
You are absolutely right. Are you going to say you can do this?
Yes.
You are absolutely right. Because those are commutative. They're multiplied, so yep.
The only thing that makes a big difference is what numbers go in the proper place.
Yes. Yeah, you can't do, well,
You can do x minus 4
Yeah.
times x plus 7.
right, that would not work.
Give you the wrong answer.
Yes.
It'll get
And
you right.
look, you just check it. If you did the FOIL on here, you'd get x squared minus 3x minus 28. You know? Now, by the way, we're not done yet, are we? Have we solved for x? This is so easy. Set this one equal to 0. Solve. X minus 7 equals 0. X equals 7. Set this one equal to 0. X plus 4 equals 0. X equals negative 4. Now you've finished the problem.
So we have to do that?
You have to do that because it solved the equation.
Okay.
Yeah. Tell you what, if you're nice to the other people in class, remind me to tell them that this question you have to solve for x. Because some people forget, and I'll take off 2 points. The ones that left early, we won't tell them?
No.
Okay.
No.
That's mean. We didn't tell them. Okay. All right. Questions on this one? All right. And you get what I did here. I just said this one equals 0, and then the other one equals 0. Okay. All right. Now, the one where you guys have to do a little bit of memorizing. If you see quadratic the first thing you can do when you get the test is like barf out the quadratic equation. I don't really care. Put it anywhere on the test, right? Solve the equation using the quadratic formula. Well, the quadratic formula is x equals negative b plus or minus square root of.
B squared minus 4 times A times C over 2 times C.
2 times a. Okay, negative b plus or minus square root of the quantity b squared minus 4ac divided by 2a. Okay, boom. The next thing, don't just think you can pick off a, b, and c right like that. You better set it equal to 0. 3x squared minus 10x equals, oops, plus a 4 equals 0.
And you gotta figure out which one is A, B, and C.
Now it's easy. A is 3, b is negative 10, and c is 4. And this is where I messed up on the answer, because I forgot to do negative b, which is positive 10.
That was confusing me on a couple of them.
Okay. All right, and then you just plug in. Negative 10 is 10. Plus or minus square root of negative 10 squared minus 4 times 3 times 4. Divided by 2 times 3. Equals 10 plus or minus square root of 100 minus, let's see, 4 times 3 is 12, times 4 is 48. 100 minus 48, 52, divided by 6. Now look, if you put that on the test and leave it like that, I'm fine. Okay? X equals that. I'll give you full credit. For homework, if you haven't gotten to these problems in homework, you still have to simplify these. And to simplify the square root of 52, you say, look, 52, square root of 52 equals 4 times 13. The square root of 4 times the square root of 13. Which means that that equals 2, because you take the square root of 4, times the square root of 13.
Yep. I heard that.
Wait.
Don't do nothing else. This is where I get my biggest problem at when I come to these equations.
Okay.
So you break it down, you go, because I wrote it down like you told me the last
Did you? Yeah, you wrote all the numbers down on the side. Yep.
I wrote them all down.
Good. 52 divides by into what? What goes into 52?
Okay, so 4 and 13.
Okay, 4 and 13. So that means square root of 52 equals the square root of 4 times the square root of 13. Can you simplify one of those?
Yes.
Which one?
Square root of 4.
Becomes?
2.
So that's 2 times square root of 13.
You know how I have to do this?
How do you have to do this?
I have to just do the square root, like I'll subtract 52 by, I divide 52 by 2, and then I do it again until I get the last answer, and then I know to put 2 in there.
Okay.
It's the long way,
But it's not always going to work that way.
No?
No.
Some of those crush my dreams.
Well, you
Yeah.
still remember that formula there. So you should do this.
Okay, do we get that now? All right, so what you would do in the homework, for those of you who haven't finished the homework, this is going to become 10 plus or minus 2 times the square root of 13. And now that can be reduced because 2 goes into 10, 5, right? Right? And then 2 goes into 6. 3 times, right? So that's going to become, so it's going to be 5 plus or minus square root of 13 over 3.
Wait a second. Isn't it supposed to be negative 10?
No, I put negative 10 and I was wrong. It's supposed to be negative 10, which means positive 10.
Yeah, okay.
So it's my fault.
That's what I said.
What? We just talked about that. Yeah. Okay, so x equals that.
Where'd you get the 5 from now?
Okay, I said, look, does 2 go into this and 2 goes into this? And 2 goes also into this?
Yes.
So what I can do is I can say that divided by 2 is 5, and that divided by 2 is 1, and that divided by 2 is 3, so it just reduces. Because look, 10 over 6 is what? You can go 2 into there, gives you 5, and 2 into there gives you 3. And then this one, 2 over 6, 2 goes into 2 once, and 2 goes into 6 3 times. So 1/3.
Oh, okay. Oh, you just
I'm just reducing it.
All right.
Just reducing it.
But we don't have to reduce it for the quiz, right?
No, I'm not going to worry about it. If you get it this far, I'll be happy. Okay?
If I get that far, I'll be happy.
All right. All right. Any other questions on the quiz?
Can you, no, I still got the other practices I can do. The
Okay,
practice
good.
Check. All right. I'm telling you the word problems, the first one.
Well, the first one is going to be one of those ones you just got to use problem-solving skills. You do have them.
You got skills, Mike. Believe in
Skills with a Z.
skills with a Z.
Yeah. All right.